So, what does it really take to build a machine learning system that can actually survive out there in the wild? Well, it all starts with challenging a core assumption, one that, frankly, is pretty dangerous, that a lot of us have about AI. We often get this picture in our heads of a machine learning model as this solitary island of brilliance, just this powerful, self-contained piece of code that works. But here's the thing, that mental model isn't just a little outdated, it's actually dangerous. You've probably heard this famous line from the poet John Donne. He wrote it way back in the 1600s, and his point was that people need to be part of a community to really thrive, right? We're all interconnected, we all depend on each other.
So, what if that exact same idea applies to our technology? What if our AI models aren't islands at all? What if they're just as deeply connected to and dependent on the world all around them? This is the crucial shift in thinking we absolutely have to make.
All right, let's pull back the curtain and take a look at the hidden connections that pretty much every AI system relies on to function.
This slide, wow, it really nails the evolution of software. We used to build things like the image you see on the left, a big monolithic design, just one giant self-contained block of code. But today, almost all modern software, and that includes ML systems, looks a lot more like the image on the right. It's modular, a whole collection of smaller, interconnected pieces that talk to each other.
And hey, there are some really good reasons for this shift. When you break a huge system into smaller parts, it becomes so much easier to handle. You can fix one little piece without breaking the whole shebang, you can test components one by one, and you can even reuse them in other projects. It's just a way smarter way to build things.
But here's the catch. This web of connections, it introduces a kind of hidden vulnerability. These systems are powerful, for sure, but they can also be incredibly fragile. So what happens when the world they depend on inevitably starts to change?
So these are the weak points. Your AI isn't sitting in some sterile lab. It's depending on data coming from another team. Maybe it's using predictions from another model, or it's even relying on some really basic assumptions about how the world works. And every single one of those dependencies is a potential point of failure, because they can, and trust me, they will, change.
Okay, let's make this real with a super simple scenario. Imagine you've built this fantastic little model that tells you when you should probably grab an umbrella on your way out the door.
Now, your model doesn't actually measure the weather itself, right? It gets its data from a totally separate upstream weather prediction model. This is a classic dependency.
And then one day, boom, it just breaks. Your predictions are all over the place, and people are getting caught in the rain, totally blaming your app. What on earth happened?
The problem wasn't in your code at all. See, unbeknownst to you, the team managing that upstream weather model retrained it using some faulty data, maybe a few years where there was unusually low rainfall. Your model, which was just trusting that data, started making terrible predictions as a result.
Okay, how about another one? This one's even more subtle. Let's say your team builds a security model. Its job is to analyze web traffic logs to spot any malicious activity.
So the data for this model comes from the web development team. They decide to do some refactoring, and in the process, they change the format of their logs. A totally normal, everyday engineering task that happens all the time.
But this tiny little change is a complete disaster for your model. The data fields it was trained to look for are now just empty. They're null. They contain no information. All of a sudden, your model is being starved of the data it needs to work, and its performance just tanks. It's a really sneaky kind of failure that can be incredibly hard to track down.
So if we know change is inevitable, and we know our systems are all interconnected, then we just can't keep building these fragile islands. We have to start designing for adaptability right from the very beginning.
This is exactly where the discipline of MLOps comes in. And it's so much more than just a buzzword. It's a fundamental shift in how we operate. It's not just about building a cool model. It's about building and maintaining the entire system around it for its whole life cycle. MLOps is really the discipline of designing for change.
And this is what that actually looks like in practice. A really solid MLOps workflow isn't just a straight line. It's a continuous loop. You prep the data, you develop the model, you automate the deployment, and then, and this is the most important part, you monitor it, constantly. This is how you catch those upstream changes before they turn into total disasters.
Now, the great news is you don't have to invent all of this from scratch. That would be a huge task. Platforms like Google Cloud's Vertex AI are built for exactly this challenge. They give you the toolkits to automate pipelines, monitor models, and manage that whole lifecycle, which lets you focus on what you do best: building the model itself.
So when you finally stop thinking about just a single model and you start thinking about the entire system, you end up with something so much more powerful.
And this brings us right back to where we started. When you stop fighting all those connections and you actually start designing for them, you don't get a fragile little island, you get a resilient, thriving ecosystem where all the different parts work together, they adapt to change, and they actually become stronger over time. And wow, this ecosystem is just unbelievably powerful. Instead of starting from zero every time, you can tap into massive foundational models like Gemini, you can pull pre-built solutions from a model garden, and you can snap everything into these automated workflows. Suddenly, your AI isn't struggling all on its own, it's part of this powerful community of tools.
So that leaves us with one final, and I think crucial, question. Take a hard look at your own ML systems. Are they truly built to be adaptable, to weather the inevitable storms of change? Or are they fragile islands, just waiting for the tide to turn?